The purpose of this video is to demonstrate the technique for administering a session of TDCS using primary motor cortex stimulation as an example. This is accomplished by first measuring the subject's head and marking the sites of stimulation. The second step of the procedure is to prepare the electrodes using the size and type appropriate for your experiment. The third step of the procedure is to place the electrodes properly on the chosen site of stimulation. The final step is to determine electrode contact, the polarity of stimulation, and to set the stimulation device settings, such as intensity and duration. Different electrode montages can vary the effects of TDCS. For example, whether cortical excitability is increased or decreased is dependent on stimulation polarity as well as other stimulation parameters.
The main advantage of TDCS is that this method, as compared to other methods of brain stimulation, such as transcranial magnetic stimulation, and also more invasive methods of brain stimulation, such as deep brain stimulation, is that TDCS is non-invasive, is safe, is non-expensive, and simple to conduct. Also, TDCS has an important feature as it induces a change in neuronal membrane threshold, so it results in an increase or decrease in neuronal firing.
The applications of this technique extend toward therapy of various forms of chronic pain. There is now solid evidence that modulation of excitability in the motor cortex leads to pain alleviation.
Though TDCS provides insights into neurotherapeutic mechanisms for chronic pain, when applied to other cortical regions, including the dorsolateral prefrontal cortex, this technique can also ameliorate neuropsychiatric disorders, such as depression and cognitive dysfunction.
Generally, individuals new to this technique will struggle because there are no strict guidelines on setting up TDCS montages and stimulation settings. Therefore, visual demonstration of this technique is critical to standardize practices across clinical studies.
Before beginning this protocol, assure that all needed materials are available. TDCS devices should be battery-driven and constant current controlled with a maximum output of a few milliamps. In some devices, the batteries can be chargeable. Using electrical outlets to power the device is not appropriate, as malfunctioning devices might deliver large intensities of electrical current without warning. The electrodes used for TDCS are generally conductive rubber electrodes enclosed in a perforated sponge saturated with electrolyte fluid. If reusable rubber electrodes are used, be sure to inspect these for wear before use. It is recommended to use perforated sponge pockets that are not too coarse, as these best absorb the electrolyte solution and provide uniform skin contact, while buffering the skin from electrochemical and pH changes. Sodium chloride solution in the concentration range of 15 to 140 millimole is also recommended to assure patient comfort while minimizing stimulation voltages. A tape measure will be needed to locate stimulus locations and elastic or rubber head straps to position the electrodes. It is important to assure that the straps are made with non-conductive material so that they do not increase conductive area if they get wet. When the subject arrives, have him or her sit comfortably in a chair to begin measurements for electrode placement. The stimulation location will be found by measuring distances on the scalp, usually using the convention of the EEG 1020 system. Choose the site of stimulation depending on your experimental approach. To localize the vertex, first measure the distance between the nasion, the point between the forehead and nose at the junction of the nasal bones, and the inion, the most prominent point of the occipital bone. Mark the point halfway between these locations using a skin marker. Next, measure the distance between the pre-auricular points, being sure to place the tape measure over the marked nasion and inion halfway point, and mark the point halfway along this auricular line. The intersection of both marked points is the vertex. To locate the primary motor cortex, or M1, calculate 20% of the auricular distance and measure this distance from the vertex along the auricular line. This spot should correspond to the C3 or C4 EEG location. This is the location that will be stimulated in this video. To locate the dorsolateral prefrontal cortex, measure 5 cm forward from the M1 location. This should correspond to the F3 or F4 EEG location, as seen here. This method of determining the stimulation site is sufficient when using traditional TDCS electrodes. For more focal TDCS, other methods of cortical localization may be needed, such as neuronavigation. Before placing the electrodes, place an elastic or rubber head strap around the subject's head under the inion. This will serve to secure the electrodes and reduce movement during stimulation. Next, prepare the sponges by saturating each side with saline solution. For a 35 cm square sponge, approximately 6 ml of solution per side should suffice. Now, inspect the skin where electrodes will be placed for signs of irritation before preparing the area for electrode placement. In case of any visible lesions, do not apply TDCS in this area. To increase conductance, move hair away from the electrode sites, clean the surface of the skin, and allow it to dry. Next, connect the electrode cables to the device. Ensure the connection polarity is correct, as the effects of TDCS are highly polarity specific. This is critical, since in the context of TDCS and electrical stimulation in general, the anode is the positive terminal where positive current flows into the body, while the cathode is the negative terminal where the positive current exits the body. Now, insert the connector cord pin for each electrode securely into the opening on the rubber inset. Then slide the rubber insets fully into the sponge pads, being sure to place the anode and cathode in the correct locations. Now, place the sponge pocket to hold the cathodal electrode underneath the elastic head strap. Here, the sponge is placed over the supraorbital region. Take care that excessive fluid is not ejected from the sponge onto the scalp during this process, as this will spread current flow across the scalp during stimulation. Next, connect the second elastic head strap to the first one according to the desired electrode montage. Here, stimulation over primary motor cortex will be demonstrated, so the sponge that will hold the anodal electrode is placed under the second elastic head strap over the M1 location. Assure that the sponges are not excessively wet, but moist enough to have good electrode contact. Turn on the TDCS device. Use your system to measure the total resistance, being the sum of the electrodes and body resistance. If the overall resistance is abnormally high, this may indicate improper electrode setup. Ideally, aim to have the impedance under 5 kiloohms. Adjust the settings for stimulation, including the intensity, time, and if applicable to your device, the sham condition setting. Here, a reliable setting for pain treatment is used, stimulation at 2.0 mA for 20 minutes. Before beginning the experiment, assure that the subject is comfortable and instruct him or her to remain relaxed and awake during TDCS. This will avoid interference, since intensive cognitive effort unrelated to the target area, as well as activation of the motor cortex via prolonged muscle contraction, has been shown to modify the effects of TDCS. Now, initiate the TDCS by pressing the Start button. To reduce any adverse effects, start by ramping up the current flow. At the beginning of stimulation, the majority of subjects will perceive a slight itching sensation, which then fades in most cases. Some subjects may experience discomfort during the initial TDCS period. In such cases, the current may be moderately decreased for a temporary period, for example by 50%, as the subject adjusts, then gradually increased back up to the desired level. Assure the subject remains comfortable, and be sure to watch for sponge movement and dehydration during stimulation. Use a syringe or a pipette to add more solution if needed through the course of the experiment. When the experiment is complete, the current flow should be ramped off as well. Of note, most subjects usually continue feeling some local sensation even after current is discontinued. Inform your subject that this is not unusual. Finally, remove the electrodes and straps and answer any final questions the subject may have before leaving. With proper setup, the TDCS device should indicate that current is flowing during active TDCS stimulation, or the device should display sham mode when running a sham stimulation procedure. Of note, even with the device indicating that current is flowing through the system, current might be shunted through the skin. In order to avoid this, it is recommended to have sufficient distance between the electrodes. According to modeling studies, we recommend this be at least 8 cm when using 5 by 7 cm electrodes. Typically, anodal stimulation results in an increase of brain excitability, whereas cathodal stimulation leads to a reduction of the cortical excitability. Robust evidence for this has been revealed in trials targeting the primary motor cortex. The variation of the electrode size leads to a variation of focal effects. With a decrease of the diameter of the electrode, a more focal stimulation can be achieved. On the other hand, by increasing electrode size, it is possible to have a functionally ineffective electrode. With session duration of 20 minutes or more, and with multiple sessions over consecutive days, the after effects of TDCS are longer lasting. An example of this is the treatment of pain syndromes. One important point is the location of the reference electrode. If an extracephalic position is chosen, the investigator should be aware of current distribution, as the reference electrode might displace the peak of induced current and modify the effects of TDCS.
Once mastered, setting up of this technique can be done in 15 minutes if it's performed properly. While attempting this procedure, it's important to remember patient's safety by ramping up and down the current flow and make sure that cables are properly connected to the device.
This technique has paved the way for researchers in multiple fields to directly modulate pain and its effects on the brain and functional systems. Following this procedure, other methods like transcranial alternating current stimulation and other methods of TDCS can be performed in order to answer additional questions on brain plasticity and cortical functions.
After watching this video, you should have a basic understanding of how to set up different TDCS montages. Sponge size, position, and stimulation settings determine which brain regions are activated by electrical current.
Don't forget that working with electric currents can be dangerous, so you should be always checking the device, checking if it's working properly. And also, because TDCS is a novel technique, you should be always asking about adverse effects during stimulation and also after stimulation. The most common adverse effects are burning sensation, tingling, and also itching under the area of the electrodes.